All right, so we have this question from 1.5. And in 1.5, it tells us that we have this function, f of x, and this is the function. And that function, f, is shown on the graph here. And it says that we want to find the slope of the secant line from x1 is equal to 0 to x2 is equal to 4. So when they give you this graph here, and they're talking about, let's find the slope of this secant line. So they're saying that this red line. So when we have, what we have found the slope of is, we would call it the slope, and it was a straight line. But in 1.5, it introduces us to the average rate of change. And the average rate of change, the concept is the same as the slope, except they use this notation like this. The function f of x sub 2 minus f of x sub 1 divided by x2 minus x1. And if you compare that to the slope formula that we have seen, which looks like this, it is really the same thing. Because remember, the slope is finding the change in the output, divided by the change in the input. And I'm using the shorthand, the triangle. It's the letter delta, a Greek letter delta, which means change in. And the slope finds us the change in the output over the change in the input. Well, the average rate of change is doing that also. But when we say average rate of change, we can be referring to not just linear lines, a linear line, but also things like this blue line, this function f. And so instead, in this problem, instead of saying find the average rate of change from this point to this point, says, well, draw a straight line through those 2 points, and let's call it the secant line. And let's find the slope of the secant line. So, but they give us the input, 0 and 4. But they don't give us the output. They just say, here's the input of 0, and then evaluate f at 0. And then they say, here's the input of 4, evaluate f at 4. So what we have to do is find what f at 0 is, and find what f at 4 is. Because once I can do that, then I can use the slope formula or this average rate of change formula and calculate that slope. So let's do that, and we're going to use the calculator to help us put it into function f. So here's my calculator. Here's function f. So I am going to put function f in here, 1.3. And then in place of x, I'm going to put 0. So wherever I have an x, I'm going to plug in 0. And then make sure as you're inputting this that you're inputting it correctly, because any error in your input can cause an error in the problem. So I end up with this number for an input of 0. Now I will input 4. And instead of me retyping all of this, what I could do instead is hit second, enter, and it'll pull down what I just typed in, and I can left arrow over, and I can change the 0 to 4. So changing my input to 4 now, and then I can hit enter. So now I have my two values, and so I'm going to put that in to my slope formula. And I'm going to say, well, I'll first label them. This was the one, and this was the other one. And I'm going to call it x1, y1, x2, y2, and I'm going to put them in here. And then I'm going to put that in my calculator now. Now, the numerator I will surround with parentheses and surround the denominator also with parentheses. And let's hit enter. Now this problem says to round to the nearest whole number. So even though I get 146.8, if it wants it rounded to the nearest whole number, I'm going to say 147. And that would be my answer to part A. Then I'm going to go over here to part B, and it says, well, the actual yearly increase from 1994 to 1998 was 139. Does the slope from part A, the slope in part A was 147. Does that slope from part A underestimate or overestimate the value? So since 147 is more than 139, you can say it overestimates the value. And the slope in part A differs from the actual average yearly increase by 8. So 147 minus 139 is 8. So those are the two things it's asking you to find in part B. And that's how you would find the slope of the secant line, or you could say the average rate of change from 0 to 4 on this function f.